and we will have a last presentation of today. Giorgia, Mauro, if you are ready, could you share your screen?
Yes, I think that Giorgia is sharing the screen, and I will use my microphone at the beginning, and I will pass it to Giorgia in the middle. So, okay, let's share the content. Here we are. So we are going to talk about how GSIM has been applied here in our institute, in Italian Statistical Institute. And in order to do this, recall that, as a matter of fact, we have used it for the conceptual representation of metadata in metadata systems in general. And we have right now two different systems devoted to statistical metadata. On the one hand, one is about structural metadata. It's named SUM, and it mainly contains information objects from the concept and the structure groups. So our main problem here is to describe data and the concepts that are used to describe data. On the other hand, there is another statistical system which is named CDSQL that contains mainly reference metadata and quality indicators, and consequently refers mainly to business, exchange, and structure groups. As a matter of fact, now in this presentation, I'm going to focus more on the structural metadata system, and Giorgia more on the reference metadata system. We would like to mention also another project which is undergoing right now in our institute, and it's named Synthesis. The idea is to have a system that contains not only reference and structural metadata for a set of short-term surveys, but also the services, and so the description of the different steps and how to perform them effectively. And this system is named Synthesis. It contains mainly not only structure group and business group, mainly contains business and concept groups. Let me show this map. This consists of all the concepts that are in GSIM, and the structural metadata system is the one in pink, let's say, while the reference metadata system is the one that has the dark blue part, while other parts of GSIM is shared by both the systems. And Synthesis, on the contrary, will contain also another part of the concepts that are included in GSIM. As a matter of fact, not all the concepts are covered by our system, but I mean, these are the boundaries between the different systems right now. And as far as the structural metadata system is concerned, we have mainly used the GSIM concepts, so I'm not going to specialize and to consider them one by one. I would like to focus just on one of those concepts, the variable one, just because for our purposes we needed to have a specialization of it, and consequently it could be useful to have a representation of how to adapt the generic statistical information model also to the purposes of the Statistical Institute. Here I write down the definition that has been given to GSIM, to the variable, the use of a concept as a characteristic of the population intended to be measured. This makes this concept quite large in its definition, larger than the one statisticians are used to have, because usually variables are a characteristic of units in a population. On the contrary, here the concept is much larger. And the examples that are being given show this. The explanatory text, which is attached to this definition, says that the variable combines the meaning of a concept with the unit type to define the characteristic that is to be measured. Sex of person, number of employees, and value of endowment are three of examples. I had other two examples, household annual income and average household annual income. Just because in our mind these two kind of variables play different roles in our systems. On the one hand, the first one, household annual income, usually is attached to what Catherine already introduced in the structural group of the unit data sets. And the unit type in that case is the household. The population, for instance, consists of all the households in Italy on the 1st of January 2017. And on each of these households, we are going to ask what's their household annual income. On the other hand, as statisticians, we are interested in the representation of a measure of what's going on a group of these units. And for instance, this representation can be given by an average. So we have the average household annual income. This usually is a measure in dimensional data set, whose population consists again of all the households in Italy in 2017, but the measure component here is the average household annual income, where the groups of households have been identified by the combination of dimensions that I reported as an example in the previous slides. Number of household components, the geographical area, the main income source of the singular households, and the year. So why I'm going to represent this difference? Now, the proposal that we have used in our system is to characterize the different variables according to something which is available in the business group of GSIM. For instance, the steps of a specific statistical program design, where these elements are given. Just because we have that aggregate data are nothing else than an elaboration of unit data sets that we already have got. And so what we are going to do is to highlight at least some components of a process design, of a process step. For instance, when we want to have a representation of a variable with a value domain which is numerical, like income, and we want a total, a median, a mean, or whatever it is, this measure that we are going to have on an aggregate set of units can be characterized on the one hand by the universe where we are going to compute this aggregation, the variable which is observed on each of the unit, for instance, income of a single household. This is going to characterize the input data set. And then we are going to also characterize this measure by the process method, for instance, the average, the total, the median, whatever it is, so that the average household income is just a composition of these elements. Why are we going to do this? For instance, our SDMX can be one of the examples when we are going to define data sets like the one that I introduced before. The one that I introduced before, like the average household annual income, I can include these in a code list or a concept scheme consisting of only elements that have a story like that one. That is, have an input consisting of micro data sets and a transformation method, a process method that has been used. And so this is what we have additionally do for structural mega-represent. And now I give the word to Giorgia for the other part.
And now we go through the reference metadata part. As already mentioned, we are using business exchange and structure groups objects to redesign our system. That indeed we have this system that was developed years ago when GSBPM or GSIM were no developed, and now our system needs to be renovated. It currently runs but needs to be renovated for technological reasons, but also to better represent the new modernized statistical processes, for example, statistics based on multiple sources. And we are proceeding in 3 steps. First of all, we are trying to map metadata concept in the system with GSIM information objects. Then we try to take advantage of GSIM to improve the system, so to design enhancements. And the third step is then also to adapt GSIM for our needs. Indeed, we have some information that is more detailed than GSIM is. Here you can see only the main metadata concepts that are used in the system. Indeed, the CDSQL is rich, complex, and highly structured. The main object is what we call the statistical process, for example, a survey that is in the center. Then all the other information are characteristics of the statistical process, starting from the general description, the frequency, the different editions, and the documentation of the observed topics. The core of the documentation are the phases of the statistical process, and for them we organize the phases in what we call operations and sub-operation, and then for them we collect information on the software used to make the operation and on the quality control actions performed to improve the quality. Indeed, SQL is a quality-oriented statistical metadata system. Actually, the system documents information about the input from the external sources, like the reporting unit that is contacted to obtain information, or the administrative registers that are obtained, and on the final outputs. We do not have information on the intermediate input-output of the process, but we hope in the future to link to the structural metadata system and obtain this information. Then the system is also a document repository where we can find legislation, questionnaires, and other methodological documents. So, concerning the mapping with the GSIM business group objects, some of them are quite simple. The statistical process corresponds to the statistical program, the addition to the cycle. Input and output are process input and process output. And the legislation is the statistical need. I saw a question on the possibility to map the legislation also as a provision agreement. Well, let's say that this it happens that you have 2 different information objects from GSIM to which you can map an element, but it depends on your business case very often. In our system, we do not manage the transmission of data and metadata directly, so it's more a matter of legislation of relevance that is connected to quality. So in our system, the role of the legislation is more than the one to define a statistical need, but you are right that it could be mapped differently. Then the easy part was this one, but we have had also to map the phases and the operations, and it was not clear at which level of GSIM we should map these items. At the end, we decided to map the phases with the business process and the operation and sub-operation with the process steps. The generalized software is a business service, and the quality control action can be mapped as statistical support program, even if we have more detailed and more structured modeling for quality control actions. Concerning the exchange group, it was quite easy to make the mapping. Questionnaire is the same, and for the different outputs, we have the product in GSIM, while reporting unit and administrative bodies are the information provider, and administrative register is the same. The second step was to take advantage of GSIM to design enhancement. And for example, in our system, we have that the phases of the workflow among the phases of the production process is fixed. And this should be improved because now the processes are more flexible. So we think that we will consider the GSIM information object process control design to help us in this work. And another step is when we notice that we need further specification and adaptation of the model. For example, for outputs, we have different kinds of outputs, volumes, press release, online database, and other things. And the information object product from GSIM needs to be further specialized. The other information object of presentation is not sufficient because the different kind of outputs are also managed differently in the system. So we need to have a further specialization. And that's all. Thank you from our side, and thank you for your attention.